In this lesson, we are going to learn more in detail the difference between distance and displacement. In the earlier video, you have learned that distance is the length of the actual path covered by the body, and displacement is the shortest distance between the initial and final position. Now let's read this sum. Here they said a body travels a distance of 15 meters from A to B and then moves a distance of 20 meters at right angles to AB. Calculate the distance and also the displacement. So here we have first the body at A, and then the body travels to B. So here is A and here is B, and it travels 15 meters from A to B. At B, it turns right angles to a point C, and according to the sum, it travels here another 20 meters to a point C. So we need to find the distance and displacement. To find the distance, we know is the actual path covered by the body. So from A, we go to B, which is 15 meter. So we have AB, which is 15 meter. Then from B, the body goes to C, which is 20 meter. So it goes to the BC is 20 meter. So the actual distance covered by the body will be AB plus BC. This is the path traveled by the body. That is 15 plus 20, and that is 35 meter. This would be the distance traveled by the body. Now to find the displacement. To know the displacement, we need to know two things. We need to know its initial position, and we need to know which is the final position, and find the distance between the initial and the final position. So in this case, we see the initial position is A here and the final position is B. So this is the initial position. It started off at A, and this is the final position. It ended up at C. And the distance between here, this AC, not AB, AC will give you the displacement. So AC gives me my displacement. Initial position A, final position C. Now how do I find AC? Here I can use Pythagoras Theorem. This is my 90 degrees. So I'll use my Pythagoras Theorem. Who is the hypotenuse here? AC. So I have AC square equal to AB square plus BC square. AC square is my displacement. AB is 15 square plus 20 square. So your AC square is 225 plus 400, and the AC square will be 625. AC will be under root of 625, and that is 25 meter. So my displacement here is 25 meter. So here you would have observed the difference, or you'd have learned the difference between distance and displacement. The distance in this case, actual path followed, is 35 meter, and the displacement in this case is 25 meter. Note one thing in this, which is greater, distance or displacement? We have seen that distance is greater than displacement. A particle moves 3 meters north, 4 meters east, and finally 6 meters south. Calculate the distance and displacement. To start with the sum, we know the north would be here. This would be the north. And however, here down, you know, is the south. This would be the east. and here would be the west. Now this is let us assume that the particle is starting from this point 0. This is the starting point, the initial position. In the first case they said it moves 3 meters north. So let's move 3 meters north. 1, 2, 3. So it is here at this point. We'll call this point as O and this point is A. Now it has moved 3 meters to the north. Then 4 meters to the east. 4 meters to the east. So here 1, 2, 3, 4. So it has come to this point now. We'll call this point as B. And then finally 4 meters to the south. 6 meters to the south. That is 1, 2, 3, 4, 5, 6. It has reached here. And we say this point as C. So we need to find distance and displacement. Let us start finding the distance. We said distance is the actual path covered by the body. So which is the actual path covered by the body? It goes here from O, it goes to A, which is 3 meters. Then from A, it goes to B, which is 4 meters. And from B, then it goes right down south, here right down like this, to C, which is 6 meters. So you'll definitely agree distance is the actual path. So distance will be OA, which is 3 meters, plus AB, which is 4 meters, plus BC, which is 6 meters. So you'll add up and this would be 13 meters would be the distance covered by the body. Next we are going to find the displacement. Now to find the displacement, always first mark your initial position and then mark your final position, because displacement only involves initial and final position. So where did the body start from? The body started from O. So this is my initial position. Where did the body end up? It went right up to A, B and ended up at C. So this is my final position. So this is my final position. And this is my initial position. And I don't need anything else. And now I have to find this OC. This OC will be my displacement. I only need to find OC. Now to find OC, see what I do. I'm going to now draw this line here. I'm going to join this here, right? And it will be equal to 4 meters. Have you seen? This is 4 meters. This also will be 4 meters. This entire, right from here, right up to C was 6 meters. And I already know this was 3 meters. OA was 3 meters. So this also will be 3 meters. Hence, this part, my lower part here, will be another 3 meters, isn't it? 3 plus 3, I get a total of 6. This green and the blue together make my entire, and the blue here make my entire 6. So now to find my OC, I'm going to use Pythagoras Theorem. And for Pythagoras Theorem, we know that hypotenuse here is OC square equal to O. I'll put this point as D. OD square plus DC square. This was 3 meters. This was also 3 here. So OC square equal to OD is 4 square plus 3 square. Your OC square is 16 plus 9. OC square is 25. So OC will be under root of 25 and OC will be 5. So this is my 5 meter. Again, initial position was O and the final position was C, and the distance between the initial and final position was 5 meter, which is displacement. So here displacement equal to 5 meter. So to go over the sum again, we first had to find distance. So we went up here 3 meters. Then we went here towards the east 4 meters. And then we went down here 6 meters. And the total 3 plus 4 plus 6 give us the distance, because that's the actual path traveled by the body. This body traveled all along this path, which was 13 meters. And to find displacement, we had to know the initial position, which was O, the final position, which was C, and the distance between this, the shortest distance between the initial and final, gave us displacement. And that we found with the help of Pythagoras theorem. We joined this here. This was 4 here, so this also was 4. And then this was here 3. This 2 was 3. And since the total was 6, from here right up to here was 6, this also turned out, this part also turned out to be 3, because 3 plus 3 is 6. And when we use Pythagoras theorem in this triangle, we use Pythagoras in this triangle, and we found our displacement. This was the displacement. Initial and final position.